Hello world! Welcome back to another CTFlearn challenge video. In this video, we'll be walking through the forensics challenge, HailCaesar. Let's get into it. You might need to write some Python to solve this challenge. Some encryption may be involved. Good luck. They give you this JPEG image right here. I have it downloaded over here for our convenience. And by the thumbnail, and if I open it up, you can see that it's a picture of a person cosplaying as Julius Caesar. So we'll close that. And what we're going to do is open up my PowerShell terminal right here. And we're already in the directory we need to be in. What we're going to do is run strings on our JPEG image. And we'll actually specify a limiter of 10. That way we don't get all this extra jargon. As you can see, we have some fake flags here. It says, Hail Caesar, airplanes sometimes cause in-flight incidents, and Flight 32 leaves soon from gate 126. These appear to be some kind of hint. And we also have a base 64 string right here we can decode. So we'll grab this and we'll paste that into CyberChef to take a look at it. Delete the first character and it decodes to plain text. I'm not going to read all this, but basically it's telling you to look at previous challenges before you solve this one because they'll help you, as this person often uploads challenges that combine forensics and cryptography. But other than that, this isn't going to be too much help. So we really need to derive what we need to do based on the false flags given prior to this base 64 chunk that it gave us inside the strings of the image. So if we come back here, there's going to be two strings of note that look like something we need to decode. It's going to be this one right here and this one right here. Now, the one you're actually going to want to do, as I'll save you the trouble of figuring out which one you need, is this one right here. So that's going to be the ciphertext we want to decode. Now, if you look at the false flags, it obviously says Hail Caesar. So Caesar has something to do with the encryption of this string. And then if you look at the first character of each of these words in the second flag, it spells ASCII. So maybe it's involving some kind of Caesar ASCII shift, because ASCII is another type of shift cipher. And then 32 to 126 would be the 94 printable characters. So it's pretty obvious what the character set is going to be in regards to that. So we're going to go ahead and take our little ciphertext down here, copy that, and paste it into the cipher identifier by decode, as that's what we're going to be using to solve this challenge. As you can see, it identifies it as an ASCII shift cipher, or at least it wants to believe that's what it is. There's actually a little more to it than that, but let's go ahead and open that, as it'll give us a good baseline to go off of. And we're going to paste our ciphertext in there. As you plainly saw, it was already in there from when I solved this prior. Then we're going to do all possible shifts and click decrypt. And if you look for CTFlearn, you know, the beginning part of the flag format, you're going to get something that looks like part of our flag right here. So we're actually going to grab this and we're going to paste it into Notepad++, like so. Now we need to figure out what the rotation, shift, whatever it is that's going to give us the rest of this flag. And it's kind of nice that it's showing up as these boxes here. That way we know what the correct length is going to be. And if we come back here, we can actually figure out what the rest of those characters are going to be by looking at a different shift. So we're going to actually look for the rest of the flag format that we didn't get, which is R in open curly brace. And at shift 51, the beginning of our flag format was actually at shift 18. I forgot to mention that when I was explaining it. But if we look at shift 51, when we do our control F here, we can actually see the rest of the flag format, because as you can see here, there's an open curly brace and then a closing curly brace. So we're going to actually copy rotation 51 here into our Notepad++ document. Now, as you can quite clearly see, this is not lining up properly. So we're going to actually line this up with our CTFlearn flag format, like so. And now you can see that it lines up perfectly with our CTFlearn flag format. However, these are on new lines, and those new lines are properly representing these periods that you see here. So we'll just get rid of the new lines and replace those with decimals, like so. And now we have a perfect alignment. We're going to go ahead and fill in the parts of the flag that we do know, and we'll just use the top one to correct it. And what you're going to do is wherever there's a blank, you're going to use the second string's value at that index and replace the blank with that character. So this blank is going to be X. These 3 blanks are going to be MUS. These 3 blanks are going to be MUS as well. This is going to be an R. And these are going to be US, like so. Our final flag ends up being Maximus Decimus Meridius. And if you look that up online, you're going to see that it's the name of the main character who's a gladiator from the movie Gladiator. That being the case, let's go ahead and copy our entire flag here. And we'll paste it here and submit. Alright, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.